guys, Dusty from Discovery Lab in Tulsa, Oklahoma, and today I'm going to be showing you guys how to use our Extranauts kit, how to explore forces and motion. Before we get started, I got a couple questions for you. Have you ever heard those words before? Forces and motion? Do you know what they mean? Well, let's talk about a famous scientist. Isaac Newton is probably most well known for his 3 laws of motion, where he discussed the way that objects will behave when they interact with each other. The first part we want to talk about is when an object is at rest. So I've got a ball right here. If I set it down right here, is it going to move? No, it's going to stay still. It's going to stay at rest. What would happen if I gave it a little flick with my finger? It'd probably move. You guys can see if I add a force to my object, it turns to go into motion. So, adding force to an object will change its motion. The other thing we're going to talk about is equal and opposite forces. Let's look at my ball again. Right now, it's not moving. It's pushing down on the table because gravity. Gravity pulls us down. But my table has to push up just as hard to lift it up. If my ball pulled harder because of gravity, then my table could push up. My table would collapse. If I had a bigger and heavier ball, gravity again is pulling down on it, and the table has to push up just as hard as this pushes down. What type of people do you think would need to know about forces in motion to do their job? Have you ever heard of an aerospace engineer? You might have. An aerospace engineer is a person who helps design and develop things like rockets, spacecraft, satellites, all sorts of amazing things that need to be able to go up into the air, into outer space, and sometimes return. They have to know about forces in motion while they design, build, and test their satellites, rockets, and spaceships. Let's discuss a little bit more about Isaac Newton and his 3 laws of motion. So if you remember, the first law, an object at rest wants to stay at rest. My balls, they want to stay at rest. They don't want to move. But an object in motion wants to stay in motion until acted upon by another force. So if I roll this ball, it keeps going until it hits my hand. Something else stops its motion. If I was to drop it on the ground would stop its motion. Some other force has to stop its motion. One of the forces that stops motion is friction, when things rub. So this ball right here would roll until friction slowed it down. Let's talk about the second law of motion. The second law of motion is net forces. We can simplify that and think about how force equals mass times acceleration. So that means the greater force an object has, it either has to be bigger or moving faster. This one's heavier than this one. If I drop them from the exact same height, they would have the same acceleration, but which one do you think would hit with greater force? This little rubber ball or this big heavy metal one? This metal one, it has a greater mass or it has greater weight. So that way, whenever they hit, this one would hit with less force than this one right here. Now, let's discuss the third law of motion. The third law of motion, for every action, there's an equal and opposite reaction. If you remember, my table has to push up just as hard as gravity pulls these guys down in order to keep them from falling. That means whenever I drop a ball, whenever they make an impact to the table, there is an equal and opposite force that pushes back against the ball. So if I drop this ball, it bounces. Every time it hits the table actually pushes back up again with the same amount of force that this guy bounces down with. So what we're going to be doing today is we're going to be thinking like an aerospace engineer. We're going to be designing, we're going to be building, and we're going to be testing a way to get an astronaut out of space. We're going to be utilizing Easter eggs, so we're calling them Extranauts while we're building these guys. Let's take a look and see what you guys have inside your kit. Get your green bag right here. This should have everything you need in order to do this experiment. Let's see what we've got in here. We've got some tissue paper, construction paper, sponge, a roll of tape. We've got some dowels, some straws. We've got some cups. We've got a rubber band or two. We've got some cotton rounds. We've got a moon sticker right here. We have a tape measure, some scissors, and then last but not least, we have our extra nut. Now our extra nut has a few things inside of it, so we're going to take those out. We've got some string, some paper clips, and a marble. Now what we're going to do is we're going to take our marble, we're going to put it back inside our egg. The reason being, if you remember, force equals mass and acceleration, this guy is really, really light as it is, and I could drop him from pretty much anywhere, and he's just going to bounce and be fine. But could a real astronaut just drop from outer space and be fine? Maybe if they weighed as much as this egg. So if we were shooting up beetles or ants or something really tiny maybe, but since humans weigh more, they would have a lot more force and they could be hurt. So what we're going to do is we're going to simulate this guy having a little more weight by dropping our marble in here. Now it's got a bit more weight, so when it hits, it's going to have a bit more force. We don't want this guy to crack, so we have to find a way to make certain that he lands nice and safely. We're going to use our moon sticker right here for our aiming. We're going to try and see if we can get it to land on the moon. So this is what we're going to try and aim at. Whenever we're dropping things down, we want to be able to get our astronaut to land safely on the moon. And the closer we are to it, the better we did. We're going to be able to measure how close we are, so we can score exactly how close we are dropping this guy. Now, there's two different ways we can do this, and I'm going to walk you through both of them. The first we can think about, if you remember Newton's second law, force equals what two things? Mass and acceleration. How heavy something is and how fast something goes. The first thing I'm going to think about is if I try and make this guy have a suit or something, is he going to get lighter or heavier? Is his mass going to go down or up? It'd go up. The more things I put on him, the more he's going to weigh. That means it's going to hit harder. So I need to think of a way to slow him down. The first thing to do is to make a parachute. How many of you guys have ever seen videos of someone parachuting from a helicopter or a plane? You might have. How many of you guys have ever seen leaves or seeds falling from trees or plants? You might have as well. Those are usually big and wide and spread out. They're pretty light as well. What happens is, whenever dandelion fluff or some more from an elm tree or someone in a parachute comes down, that big wide parachute, because it's so light but so big, it catches a lot of air. And if you remember Newton's third law, for every action there's a what? An equal and opposite reaction. So as that parachute pushes down against the air pushes back up against it. So we're going to try and create a parachute. It's going to be nice and big and be able to catch enough air to slow down my parachuting guy, my little astronaut, so he hits with as little force as possible. So let's see. I think I'm going to grab some of my tissue paper. I'm going to get one big sheet right here. And now parachutes tend to be fairly round. And what I'm going to do is I'm going to try and cut this guy into a circle. I'm going to show you a really quick way to do that. So you can see I've got it in quarters right here. If you've ever done snowflakes, this is what I'm going to kind of do. I'm going to fold it to a corner so I make kind of a pie slice like this right here. And I'm going to fold it again and making it smaller and smaller and smaller. I'm going to fold it one more time. So I have this really tiny piece right here. Now here's the fun part. All you have to do is find that line right there and cut it fairly straight across. Cut off the tip right there, and then as I unfold it, I've almost got a pretty close to perfect circle right there. I think that's going to be great for my parachute right there. Now, I'm trying to think about what does a parachute look like? How many times have I seen a parachute? Now, generally, if I've seen one that's like this, they've got a couple of different points that they're attached to the person or the skydiver, whoever's coming down. But I want to give this guy a little bit of extra protection right here. So what I'm going to do is I'm going to put him inside kind of a basket, I think is what I'm going to do. So I am going to get one of my cups right here. This is going to be my basket. It's going to look maybe a bit more like a hot air balloon. Now, if I look at this plastic right here, this is still pretty hard. How many of you guys have ever fallen on something that was kind of hard, like a rock or the cement or the ice? Did it feel very nice? Probably not. How many of you guys ride a bike or skateboard or scooter or something like that? Pretty fun, right? But always wear safety equipment. That's because that helps protect your head, your knees, things like that might hurt if you hit with a lot of force. Now, if you look at those guys have got foam or some type of nice padding in there that helps absorb a lot of that force. You remember my two balls that I had before? My wooden one and my rubber one? That rubber one could squish in a little bit. So it hit actually with less force. So instead of it all going clunk at once, it slowed it down. So what I'm going to do is I'm going to use this nice squishy foam guy right here, stuff them in here, just like it's a helmet. And let's see now, it's not wanting to stay, so I need to put a little bit of tape. That's why we give you a whole roll of tape, because you need a lot of tape. Now, whenever you're using your tape, make certain that you get a good amount. I like to use at least 6 inches. If you use much less than that, I feel like it doesn't always want to stick right for you. So what I'm going to do is I'm going to take and I'm going to stick my egg in right there, and then I'm going to tape over the top to make certain he stays in there. There we go. So now you can see he's kind of sitting right on top of there. Now, if I dropped him like this, I'd still be worried, he could hit the other way. I want him to hit with as little force as possible. So let's get our parachute attached. So I'm going to get my string. I think I need to cut it into 4 pieces. So I'm going to do it in half. So I'd have 2 even pieces. I'm going to do that again. So now I've got 4 even pieces. And I'm just going to cut this end, and then I'm going to cut this end. Now I should have 1, 2, 3, 4 even pieces. I'm going to attach them on 4 corners, kind of, my parachute. Lay those guys down. This one right here. And I'm going to use a little piece of tape. Now, make certain you tape things nice and flat and secure. You don't want things to slide or move too much, because if it fell off whenever we were trying to test this guy, that wouldn't be good for our little extra nut. He might crack. Now, if for any reason in your testing your extra nut cracks, well, don't worry. Luckily enough, he can get stuck back together. There's a little bit of tape, put a little bit of tape on him, or if you have another egg hanging around, you can always substitute with a different egg, or if you're really adventurous, you can substitute with a real egg. Make sure you ask mom, dad, grandma, grandpa, auntie, uncle, whoever, for permission first. That might be breakfast. They don't want you smashing their eggs all the time. Alright, so I've got this guy's attached right here. Now the next part is I'm going to attach it to my little basket. So I'm going to need 4 more pieces of tape. Now, this is just a suggestion that I had. You guys can come up with your own. I want you guys to think about what you've seen in movies, what you've seen in video games, what you've seen in real life. I know you guys have probably seen a lot of different parachutes, a lot of really cool gadgets and stuff like that, and you probably have some amazing ideas. This is just my idea. So if yours looks absolutely nothing like mine, that's okay. We're all going to have slightly different ideas. And the fun thing is, if you look at a lot of things that are developed for space, they have all the most fun, amazing ideas. One of the coolest things I know is they actually looked at origami. Have you guys ever done that before? Origami is pretty fun, but did you know they actually use origami to get things into space? It's true. They have to keep things nice and small, and so whenever they fold it up like origami, then it can unfold. So this guy unfortunately doesn't have anything cool like that in it, but I think, let's test this guy out. Let's see now. Well, there we go. I think that's a pretty decent little parachute right there. So I could test this guy. I could set my moon down on the ground, and I could find a nice, big, high spot, and I could test it. We're going to wait. We're going to test this guy later, because I want to build my second type of protection for this guy. So I'm going to pull him out, luckily enough. So this is just like a seatbelt that holds him in. He can slide right out of there. Now the next thing is, I want to build a suit that's going to protect him. So instead of actually slowing down his fall, reducing that acceleration, I'm going to focus a bit more on Newton's third law. For every action, there's an equal and opposite reaction. So I'm going to take advantage of a couple of things. So how many of you guys have ever seen a big airbag that like the stunt guys jump on, or like a big box of cardboard? So if you ever watch movies and the guy does like, oh, and the girl's like, crazy jump, they land on a big airbag or a big bunch of cardboard boxes. What happens is those are able to absorb a lot of the force because, remember how I said all that air pushes against my parachute? All those cardboard boxes push up a little bit, and as they push up, they slow your descent, and so it slows you down so you don't hit as hard. So I'm going to think about that kind of an airbag or something that's going to kind of crumple or crunch instead of my egg. So for that, I think I'm going to use paper. This paper is going to crumple and crunch pretty easily, I think. So I'm going to try and make something that's going to be kind of nice and big, be able to crumple and crunch. And I think I'm going to use these cups as well, because I think they're going to crumple and crunch pretty nicely as well. So I'm going to take my paper, and I think I'm going to try and make kind of a nice little accordion fold. So what that means is I'm going to cut this guy right down the middle. And see if I can kind of get a little bit of a, like I said, airbag type thing. Now, remember, guys, you don't have to do this. If you guys could think of something else, some other ones I've seen have been really cool. Some people have used a lot of like sticks and stuff like that that are going to kind of spread out and where it's going to really have a lot of surface area it hits on. So that's another thing. You can spread it out. So instead of hitting on one little point right here, spread out that so that way there's more force on a greater area. Because remember, like I said, the more it touches, the more it's going to push back and slow things down. So if it hits on one little point, it's not going to be great. But if it hits on a lot of points, it'll be pretty good. So I'm going to accordion fold this guy so that way it's kind of taking up a little bit more space. I think. There we go. Kind of a little accordion fold, kind of like you're making a paper fan. There we go. I think that's going to be nice. That's going to have a pretty good squish maybe. And I'm going to put a little bit of tape on that so that way it doesn't fall apart on me. So I want you guys to really think about what you're doing here. Don't just start throwing things together. Have a good plan in mind, because I guarantee you it's going to be a lot better if you have an idea before you get started. So that way then you can see it through. If you just kind of start sticking things together, it might not turn out the way that you had envisioned. And you might have some issues if you don't have like a grand idea to begin with. I like to draw sometimes. I've been thinking about this all morning, so I didn't have to draw, but if you guys don't have an idea just right off the top of your head, try and draw it up. All right, so here we go. So I've got this little part right here, so you can see I've got some good little cushion right here. I think that's going to be able to stop a lot of it, but to be extra safe, what I'm going to do is I'm actually going to put some of these little cotton rounds right here, because these guys are nice and soft. So I'm actually going to take and stick these inside of this to make it even softer. And I definitely want to be able to get my astronaut out. What good is a spaceship if the astronaut can't get out of it if he's stuck in there? I'm trying to put those guys around right there. And I'm going to put a little bit on the bottom right here. Tape this guy down right here. I'm going to kind of make it, it's going to look a little bit like a boat, I think, whatever I'm done is kind of the final look that I'm going to have with this guy. Just kind of get this guy in here nice and soft. Oops. Fold this one over right here. Really get it inside. Alright. So you guys can see I've kind of put a nice little bit of cotton around here. I'm going to put a little bit more tape to make certain it doesn't fall off. Looks like it's a kind of boat-like. And I think that's going to be pretty nice because I've got that accordion fold right there. Now, what I could do is I could stick a cup over the top of this, kind of like in a little bit of extra helmet. I could put some of these guys on the bottom to kind of spread it out a little bit more. But I think this guy right here is looking pretty good. Just going to tuck this one in right here. Oh, my tape came like that. That's the problem, is sometimes the tape comes undone. And you guys can see, I'm not doing this perfectly the first time, so trust me, there is no perfect way to do this. It's all about you guys exploring and figuring things out. Now, even people on Earth have to do stuff like this. Your car that you ride in and your bike that you ride on, we talked about bike helmets, they use a lot of the same ideas in science to protect you. Alright, so there we go. I think that guy's going to be pretty alright. I think he's going to be nice. He's got this kind of crumple zone right here, and he's got this nice soft pillow. And then I just pull him out whenever he's done, and it's not stuck in there. So I think this one right here is going to be okay to test, and I think this one's going to be okay to test. So let's go ahead and let's test these and see how well I did. Okay, guys. I've built both ways to help protect my astronaut. I've built my suit that's going to help cushion that fall, and then I've built my parachute that's going to help slow that fall. Now it's time to test it. I've got my moon sticker. What I'm going to do is I'm going to set it down on a spot right in front of me, and you want to select a place that's a nice level and flat and fairly hard. You don't want to drop this on the carpet or someplace that's kind of soft. The reason being because if I drop this on a big old pile of marshmallows, it really wouldn't matter about my suit, would it? So we really actually want to test it. That's why if you've ever seen where they test cars, they run them into brick walls. So this is going to be our brick wall right here. So we're going to test it, and we're going to test how close we can get. So I've got my tape measure right here. It's going to let me know exactly how close I am to hitting the moon. So first thing first, you're going to pick up whichever one you want to test first. I'm testing my suit right here, my little crumpled up. Got my paper right there. It's got my cotton right there to soften it. I'm going to hold it about head height. So kind of eyeball it. That looks to be about head height right here. I'm going to see how close I can get to my moon. And 3, 2, 1. Oh, I was a little ways off, wasn't I? Let's see now. So I'm going to measure, and I'm about 10 inches away. Oof, that was a bad shot. I better try again. Let's do it with my parachute. But wait, I need to test and make certain that my egg has survived. So let's see now. Will he come out? Yeah, he'll come out, so he's not stuck in there. And do we have any cracks? Hey, he survived. Good job. So that means that this one worked to get him down safely. It was a little hard to aim, so this is something to think about. How easy is this to aim? Think about things that get aimed or things that get dropped and stuff like this. This isn't anything that kind of flies through the air very easily, is it? So that's something to think about when I'm redesigning this, is maybe make it easier to drop it straight down. Now let's test my parachute. So I'm going to set him in here, make sure he's all together, put him in his little seat belt with his foam right here. And again, I'm going to hold it about head height. I'm going to try and hold that up so it's about right there and try to aim it. And, oh, drifted way off course. Let's see how far away I was. Oh man, I think that's longer than 10 inches. Oh, it's way longer than 10 inches. Oh goodness, 25 inches. Oh wait, no, I didn't. Oh no, we gotta measure. Oh, 26 inches. That one was worse, but did you see how slowly it fell? That's because the parachute, remember, that third wall motion, as it hit all the air on its way down, that air pushes back up and slows it down. Well, I think that my egg, let's check, survived both drops. Now, I know I need to work on my accuracy, but if I want an extra challenge, I could drop it from even higher. Let's do that. All right, so you can see I'm up here on top of my step ladder. If you're doing this, make certain you do have an adult or a grown-up or someone to help you out, and you have permission to be on something like this because it can be dangerous. Only use a step stool or a ladder. Don't climb on a chair or a table or anything like that. That could be unsafe. I'm going to test this from a higher fall. Now, if you remember, force equals what two things? Mass times acceleration. My mass hasn't changed, but if I drop it from higher up, it should fall faster, right? Because gravity is going to be able to pull it for longer. So that means the higher I drop it, the harder it should hit. So I'm going to test this guy, and again, I'm trying to aim and see how close I can get to my little moon sticker right here. Ooh, it's harder to see all the way up here, so I'm going to have to get out right here, and I'm going to try and compensate for the little drift that I had last time. It kind of moved on me to get it nice and open. All right, let's see now. If I can get this guy to fall straight, let's see. And all the way up, and let's see. 3, 2, 1. Oh, that one was pretty close too. The last one, wasn't it? Oh, you think I got closer or further away? Let's see. So, let's measure again. 21 inches. Hey, I was a whole 4 inches closer this time, so that's pretty good. I think I still need to work on my aim, guys. What do you think? Well, hopefully you guys have as much luck as I did in testing your astronauts and their way to protect them. Remember, do both, a parachute and a suit. If you guys want, you can extend the activity by dropping them from even higher or creating different versions of your suits and finding the best one. Make sure you graph how far away you were and figure out which one was the best at getting the closest to the moon. Hopefully you guys had fun doing this experiment with me. Before we finish up, I've got a few questions for you guys. First of all, do you remember all of Newton's laws of motion? can you tell me exactly when in your experiment each one was relevant? How many of you guys noticed a pattern in the way that your extronaut fell? How many of you guys think you know when your extronaut had the most speed? At what part do you think your extronaut had the most force? What were some things that you had to change or modify to make your extronaut fall slower, safer, or more accurately? If you had a job like this, do you think you'd find it fun designing things to protect people or maybe eggs? All right, I think those are all the questions I have for today. I'm excited to see what you guys find out and what you guys can come up with. Thanks for hanging out and have a great day, guys.